Hello, so we are back into pandas and I wanted to make a video about 3D bar charts, but before that let's talk about binning because we're gonna need that. So binning is the action to regroup informations from a bigger dataset. So let's say that you have people's ages going here from 0 to 100, right? Well, binning would be for you to choose different categories of people and group them with boundaries to those groups. So for example, you could say that from 0 to 12, you are a child, and that would be my first bin. But then you could say that from 12 to 18, maybe you're gonna be a teenager, and then maybe an active adult, and you can have something around here, I don't know, around 65 or something, and then here is retired people or seniors, depending on what you're working on. So binning is going to give you the ability to create categories so that your values stop being a continuous set of values but groups with actual definitions. And this is something you basically do with most figures automatically. When you're creating a bar chart, you're usually using a reference that is going to be, for example, your different I don't know, ages, and you could say that you have something like this, and you would have your category 1, 2, 3 and 4. So binning is going to be core to you using pandas, and it's nice to know the fast and easy ways and the more specific ways of doing it, and that's kind of what we're going to be checking out today. Okay, so let's start with the drawings and just get into some binning with something pretty simple. I pre-imported pandas, numpy and matplotlib to be able to do core basics of the examples, and we're just gonna now create a data frame. So pd.dataframe, and this data frame is going to take a dictionary. We're going to call them values, and those values are going to be np.random, and I think it's randint, and those numbers are going to go from 0 to 100. So 101 is excluded from this this array, and we want 500 values for it to be nice. Sounds fair. And then let's check out this data frame. Sorry. Okay, we can see that we have 500 values. The mean is around 48, so I guess it's statistically okay. Overall, the numbers are pretty low compared to the different informations in there, and obviously our data frame is pretty basic. We just have like normal values and an index. So now, how are we going to bin this? You've got multiple big ways, and we're going to start with qcut. So what we're going to do is create a new column, because what qcut is going to do is analyze your whole data set, your whole series, and then like cut it into even marks, and then give its own bin to every value. So what you're going to get back is a series, and this series we're going to make a column. So let's say that my new data frame column is going to be called my bins, and that this column is going to be a pd.qcut. So note that it is a pandas method. We're not within our data frames abilities and methods, okay? But the data frame, or should I say the column we want, is going to be a parameter of the qcut function, and this is going to be my values column. And those values, we want to divide them in bins, and qcut allows us to do that very fast just by saying that the q is going to be, for example, 4. And what this is going to do is just like check out my values, cut them in 4, and then populate those 4 bins that are even in my data frame with the values that are in there. So let's see what that feels like by calling the head of my new df data frame, and you can see that now my bins column is populated with the the bin that was generated, and you can see that this bin is minus 0.001 going to 24, meaning that the first bin, if you divide 100 by 4, is going to be 0 to 25, but 25 excluded and 0 included. So in the notation of pandas, you can see that this parenthesis is indicating that this minus 0.001 is not included, but the 24 is, thanks to the bracket. So this means that now we should have bins that just go for 25 values, 0 to 24, 25 to 74, etc, etc. All those are then going to be populated in my data frame, and every value is going to have its category or its bin. So if I do something like df of my bins, and I do .unique, it should be interesting. So you can see that we have those bins here in the list, and you also have information there of the category of those bins, and you can see that it's exactly that. It goes all 25 values up until 100. So whatever I do, this function is going to cut even and create bins that are even within the percentile that I'm indicating. So you can just do that basically, and I could go and have like 10 bins, okay? And now those 10 bins are going to just work as well, and logically those 10 bins are going from 10 values to 10 values, right? Nothing too complicated here. But you might want to do something a bit more practical than having those automated bins in there. And this is where you can do something pretty interesting, and it's adding the name of the bins. And let's make that a bit more easy by saying 2 bins, or maybe 3. And then we're going to say that the labels are going to be young, adult, and old. And all this is going to become bad. Okay, let's do that the old way. And all this within brackets, because we need the list here. And what am I going to get? Boom! So my bins are now named with my labels. So instead of having like a first like bin that's going to be hard to read, I can now have proper categories, with young people being 7, adults being 51, and old being 90, adults old, for example. So just with this additional parameter, you see that you can now do something way more interesting with those bins and give them an actual name. But maybe within your code, you're going to have something a bit more complex to show off or to use. And this is where you might want to use a previous list that you have, for example. And you can do that. For example, if I have bins values that I need to use, and those bins values are like 0, 0.2, 0.4, 0.8, and 1. Okay, so here I didn't divide perfectly, right? I have like 2, it's going from 2 to 2 to 4 and 2. And maybe it's interesting for some kind of work that you're doing. And then I can create a variable that's going to be my bin labels, and I'm going to call them like A, B, C, and D. Okay, well now I can just do df of a new bins column, bins2, and call my pd.queue_cut of df values. And in here I'm gonna say that my queue is binsval and my labels are bins labels. And here we are. So basically what we did is just the same thing as before, but using lists that were previously customly made, giving you even more control on the Q-cut and making it very useful. The thing is that the only limitation of Q-cut is that it's always going to be percentiles. Sorry, it's always going to be like a division of your total. So here I'm going from 0 to 0.2, 0.4, 0.8. Like I cannot go into a specific value. I cannot say by myself 0 to 15. I would have to calculate what the percentile of 15, but not like specifically say it to pandas. But that's why there's an other function that is cut. And cut is a little more customizable, and maybe it would be nice to do it with Twitch data. So let's go with this. So here we're going to create a new table T, and we're going to say pd.read CSV. I should have a file. I think I imported it. So it's Twitch data update.csv. And let's see if it's working or if I didn't do my homework. It is great. So I used that for a previous video, and this is just a lot of information about like watch times and streaming and peak viewers, average viewers that we're going to be using. And let's just apply cut to it once, and then we'll switch later on to our 3D bar chart video. So my values that are interesting here might be maybe my peak viewers, for example. Okay, let's just check on the peak viewers. Well, my bins here, okay, my bins list is going to be, let's say 0 to 500, being like an average like streamer that's starting to have good viewership. Maybe 5,000 to the people making a lot of views, then 10,000 for people that like are really famous, 100,000 for people that are like blowing things on the internet for some reason, and then let's cap it at 700,000 because I believe I checked it out and there's no values above that. Then my bin's name are not gonna be too complicated. We're just gonna say 1, 2, 3, 4, 5, because this is not very important right now. And then we're going to say that T of peak size is going to be a pd.cut. And we're going to again use as a parameter the series that we need. So it's going to be peak viewers like this. And our bins are going to be bins list, and our labels are going to be bins names. Okay, so you can see that this is exactly the same as Qcut, except we didn't use percentiles here, we used specific exact values. And in the same way as before, you're going to have this like included excluded thing that's going to be defined by cut, and that's going to create your bins. So let's now watch what that does to our data frame. And we have an error, bins must be increased okay, I'm not pronouncing this. Is there a 0 too much here? Sounds like it. 500, 5,000 here, and lacking a 0 here. I should have copied that, like really. Okay, so here we are, and we have our peak size here. Let's check out peak size dot unique, and we have them there. Okay, great. Let's check out the head again. See that all the top streamers are category 5, obviously. What else do I have for you? Well, I guess that's all for today. We can check out a few more details in the next video when we're gonna do the 3D bar chart. This is not much more complicated than that, really. So experiment with it, try it out, and you should see that it's not very complicated. So I'll see you around for the next video. Bye. Okay, so I was gonna stop the video there, but I realized that I didn't touch on a few last parameters of cut that I think are pretty interesting. So first of all, you can affect what is or is not included in your bin using multiple parameters. The first one is simply right. Right is a boolean that is by default set on true, but if you set it on false, it means that the rightmost value of your bin, for example here 0 to 500, the rightmost side 500 is not going to be included anymore in the bin, but by default it is. You can also do that with another parameter, which is include lowest, I think, and include lowest is also set to true or false, and is going to set up whether or not the first interval should be left inclusive or not. Same thing, making you way more precise with your binning. But one last one that I wanted to go through and that can be very useful, I bet, is the ordered parameter. Because you could see that when we returned bins earlier, here you have a list of bins that's returned, and that's like giving them like priorities, like sizes, and telling you like the first bin is smaller than the second one, is smaller than the next one, etc, etc. So because they're ordered, so they have values compared to each other. It's like this one, its value is 1 and this one is 2, you see. So those bins are ordered, and you can actually do that so that it's not. And what's nice is that it gives you the ability to make bins very customizable. And for example, if my bin's name here happened to be, for example, instead of 1, 2, 3, 4, 5, let's say that I want to have the extremes and the average. So we're going to have the extremes being 1 and 1, and then the average being 2 and 2, and 3 is going to be the super average, for example. Well, if I want that to work, I cannot use it this way. Okay, if I reset my table and I try it, I'm going to have an error, and it's saying labels must be unique. If ordered equal true, pass ordered equal false for duplicate labels. That's exactly what happened to me earlier when I made the typos, right? And so if I say ordered equal false, then I get it. I have them, and you can see that now my peak size is of category 1 for my biggest streamers. So now I packed together all the streamers with an extreme value, whether it's very low or very high, and all the 2s and all the 3s, using those bins up there. So that's very useful. I really wanted to showcase this information in the video. But for everything else, I'm gonna put the links in the description below for you to have all the documentation I used and to just read it, because it's way better than just videos. Alright, so I guess I'll see you around for the 3D bar chart. Have a good day, bye!